Hello, my name is Hisham Hussein. My ID is CST2509087, and today I'll be presenting about interrelationship between economics and calculus. So, okay, let's start. Let's go to the first slide. So, let's talk about economics and calculus. So, in economics, firms constantly make decisions such as how much to produce and how to minimize costs. So, these quantities do not change suddenly, but change continuously. As in life, normally things change continuously, not at once. So, in this presentation, we focus on how derivatives are applied to cost analysis, which is an important concept in economics. Okay, so here we have stated, derivatives allow us to measure rate of change, find maximum cost, and maximize profit. So we're going to look at those. So let's go to the next slide. So let's look at why cost analysis matters. So cost analysis is important because it directly affects profit and business decision. So for example, a firm wants to know how cost changes when production increases. So they can use calculus. So when they use calculus, firms can find the most efficient level of production and avoid unnecessary expenses, because as we have stated in the previous slide, that it can minimize the cost and operate also efficiently. It makes the business to become efficient. Let's go to the next slide. Okay, now let's talk about the cost analysis itself. Why? First, we talked about why it matters. Now we talk about the cost analysis itself. Okay, so let's talk about the cost function. So in economics, the total cost is represented by a cost function, which is Cx. So that is the total cost. So where x is the number of units produced, the x in C is the number of units produced. So the cost function usually includes fixed costs, such as rent, and variable costs such as materials and labor. So a common example is a quadratic function, which models increasing production costs. So I've given you an example. I hope you can understand from that. The next slide. Okay, so let's talk about the average cost now. So what is the average cost? So average cost is defined as the total cost divided by the number of units produced, as like a normal average. Okay, so it tells us how much it costs to produce 1 unit of average on average. So businesses use average cost to decide pricing and to remain competitive in the market. So this is the formula for the average cost, which is the average cost divided by the number of produced units. So let's go to the next slide. Now let's talk about marginal costs. So what is marginal cost? It is what is found by taking the derivative of the cost function. So what we are talking about is derivative. So it is found by taking the derivative of the cost function. So it represents the costs of producing 1 additional unit. So marginal cost is very important because it helps firms decide whether increasing production is beneficial or not. Now let's talk about using derivatives in cost analysis. So how can we apply this? So by using derivatives, we can find the minimum point of the average cost production. So this occurs when the derivative of average cost is zero. Okay. At this point, the firm operates most efficiently with the lowest cost per unit. So this is the formula: A multiplied by the derivative of cost and the unit, which should be equal to 0. This is when the firm knows that they are operating efficiently.
I am Akhtar Suraya. Today I will be discussing revenue function. In economics, we will see how mathematical tools help businesses determine the best production level to earn the highest income. I will explain total revenue function, the concept of marginal revenue, average revenue, the vital relationship between MR and AR, and finalizing maximizing revenue using calculus. Total revenue function, Rx, is the total income from sales. It calculated as price multiplied by quantity. In our book publishing example, if the price is 10x minus 0.1x, the revenue function is 10x minus 0.1x square. As shown in the blue curve on the graph, the revenue does not increase forever. It reaches a peak and then declines. Marginal revenue represents the incremental income gain from selling on additional unit. Derived from the revenue function, we get MR equal 10 minus 0.2x. Analyzing this function reveals 3 critical business state growth phrase. As long as MR is positive, total revenue is still increasing. The peak, when the MR reach 0, the business has achieved its maximum revenue. Diminishing returns, a negative MR indicates that price reduction have become too aggressive, causing the total income to decline. Take 30,000 unit mark as an example. The MR is 4. The positive value confirm that the market is not yet saturated. Increasing production remain a profitable decision. Moving to average revenue, which is the revenue per unit sold. Mathematically, AR equal Rx over X. In our case, dividing the revenue function, X give us 10x minus 0.1x. This result is identical to our price function, proving that average function revenue is always equal to price. Now let's talk about the relationship between MR and AR. Mathematically, as shown in the graph, the red line MR line is steeper than the blue AR line. In fact, for any linear demand curve, MR drop exactly twice as fast as AR. From a business perspective, this happened because to sell more, we must lower the price for all units, not just last one. This means the actual gain from one extra sale is always less than the price itself. Simply put, MRE will always stay below AR. To maximizing our revenue, we simply find the point where a marginal revenue is 0. Solving 10 minus 0.2x equals 0 give us an optimal quantity 50,000 books, resulting in a maximum revenue of ringgit 2,50,000. The graph and the status table here confirm this perfectly. At 40 units, MR is still positive, so revenue is rising. But at 50 units, MR turns negative, causing revenue to drop. This proves that 50 units is our absolute peak. Thank you.
Thank you, Soraya. I will continue the presentation by talking about profit maximization and its application in economics. Economic studies how firms make decisions related to the production, cost, and profit. One of the main goals of the firms is to maximize profit, which means earning from highest possible profit from their production activities. Profit depends on two main components, revenue and cost. Calculus helps us to analyze how profit changes when the level of output changes. Profit is defined using the profit function. Profit is equal to total revenue minus total cost. In this function, Rx represents total revenue, Cx represents total cost, and x represents the number of units produced. As output increases and decreases, both revenue and cost change, which causes profit to change as well. To find the level of output that gives maximum profit, we use derivatives. Derivatives measure a rate of change of a function by making the first derivative of the profit function and setting it to equal to zero, we can find critical points. These points show where profit may reach a maximum or minimum value. However, not all critical points give maximum profit. To confirm that at a critical point gives a maximum profit, we use the second derivative test. If the second derivative of the profit function is negative, the profit curve is concave down, which means the profit is maximized at this point. Profit maximization is important because it helps firms to make better production decisions. It allows firms to avoid overproduction, improve efficiency, and choose optimal pricing strategy. This shows how calculus plays an important role in real-world economic decision making. That's all for my part on profit maximization. I have discussed how profit depends on revenue and cost, and how derivatives help firms and the optimal production level. Now, I would like to pass the presentation to my teammate Madhyar, who will continue by explaining real-world examples and the conclusion of our presentation.
Now that we understand the theory behind the second derivative test, next one, real-world example and overall wrap-up. Let's solve a real business problem. Imagine we are managing a tech company making smartwatches. We have our cost function, which Hisham explained involves fixed and variable costs. We also have our demand function. Our goal is simple: calculate the exact production number to maximize profit. First, we build the revenue function as Soraya showed us. Then we subtract cost to get the profit function. To find the maximum, we apply the derivative. Solving for 0 gives us x equal to 40. This is the power of calculus. It transforms complex market data into a single precise target for our factory. Next one, we focused on profit today, but calculus is used everywhere in economics. We use derivatives to calculate elasticity of demand, understanding how sensitive customers are to price change. We also use it in inventory control to minimize storage costs, and advanced models even use integrals to calculate consumer surplus. So to conclude Group 12's presentation, our first member Hisham showed us that understanding a cost is the foundation of any business. Soraya demonstrated how revenue behaves and how marginal revenue drives growth. Daniel explained the mathematical rules for profit maximization using derivatives, and together these components prove that calculus is not just abstract math, it's an essential tool for making smart, efficient, and profitable economic decisions. Thank you for listening.